Now we're going to look at solving trig equations, but we are going to be solving them in radians. So like with degrees, here is how we find each angle measurement. So you place your angles in the correct quadrant. If it's in the first quadrant, whatever x is, which is your reference angle is the answer. In quadrant 2, we do pi minus x because we're short of getting to pi radians. Quadrant 3, we do pi plus our reference angle because we've gone past the x-axis. That's why we're adding it. And then in the fourth quadrant, we are short of 2 pi, so we do 2 pi minus whatever our reference angle is. And remember, when it's quadrantal, we've got 0, the y-axis is pi over 2, then pi, and then 3 pi over 2. So anytime our angle's over here, like with degrees, we're going to call it 0 instead of 360, or 2 pi in this case. So let's look at an example. So find theta so that theta is between 0 and 2 pi. Okay, and we're including 0, not 2 pi. So for number 1, they've given us the cosecant ratio. Okay. This number's been rationalized. So I need to unrationalize it. So I'm going to move that root 3 back down. Cosecant goes with sine. So that'll be hypotenuse over opposite. So where my opposite side is positive, that's going to be on the top. Okay, so my hypotenuse is 2. My opposite is root 3. This side will be 1. So then my reference angle. Okay, it's across from the root 3, which is 60 degrees. But since we're in radians, I'm going to label it in radians. And I didn't label this other triangle, and that's fine. If you want to label both triangles, you can, but you only have to label one. So now in quadrant 1, we just use x, whatever our reference angle is, that's going to be our answer. In quadrant 2, we're going to subtract it from x. We're going to subtract our reference angle from pi because we have not quite gotten to the x-axis yet. So these two angle measures in quadrant 1, that's going to be pi over 3, and then in quadrant 2, this is going to be like 3 pi over 3 minus 1 pi over 3. So that'll be 2 pi over 3. Now for this next example, we've got cotangent equals -1. So that's -1 over 1. Cotangent is adjacent over opposite, the reciprocal of tangent. Okay. Now this is a 45, 45, 90 triangle. Okay, this isn't quadrantal. Sometimes I'll see people make this a quadrantal angle, but it is only quadrantal if your hypotenuse and either your adjacent or opposite are both 1. Okay, so these we know are the sides of a 45, 45, 90 triangle. So cotangent will be negative in quadrants 2 and 4, where your adjacent and opposite have opposite signs. So that'll be a root 2 right there. Making my reference angle in both triangles pi over 4. Okay. Again, I'm just going to label one of the triangles. You can label both. You can label this one instead of this one. Sometimes people like to label both just to make sure they have it in the right spot, and they can make sure their sides make sense. Whether you label one or both, that's up to you. Okay. So our reference angle in both triangles is pi over 4. So in quadrant 2, that's pi minus x. In quadrant 4, that'll be 2 pi minus x, because in this quadrant, we're just short of 2 pi. So these angle measures, so pi minus pi over 4, so that's like 4 pi over 4 minus 1 pi over 4. That'll be 3 pi over 4. And then in quadrant 4, that's 2 pi, which is like 8 pi over 4. So 8 pi over 4 minus 1 pi over 4, 7 pi over 4. Now let's look at some more examples. So we have cosine of theta equals root 3 over 2. So this is adjacent over hypotenuse. So again, this will be a 30, 60, 90 triangle. So cosine's positive on the right side, where our adjacent side is positive. So I'm going to draw my two triangles there. My adjacent is root 3, my hypotenuse is 2, that would be 1. So now my reference angle across from the 1, that would be 30 degrees, which is pi over 6. So in quadrant 1, our answer is just whatever the reference angle is. Then in quadrant 4, I'm doing 2 pi minus pi over 6. So 2 pi, that's 12 pi over 6. So 12 pi over 6 minus 1 pi over 6 is going to give us an angle of 11 pi over 6. So for this next one, we have cosecant equal to -1. So that's -1 over 1. Cosecant goes with sine, so that's going to be hypotenuse over the opposite. I know my hypotenuse can never be negative, so that means the opposite side is negative. And then I have to decide whether this is triangles in a quadrant, whether it's quadrantal, or whether it's no solution. Okay. So since my hypotenuse is the same as the opposite, that is going to make this a quadrantal angle. Okay. So we're looking for where our opposite side is -1. Remember, opposite goes with sine, which is our y value. So our y value is going to be 0. Sorry, our y value is going to be -1 on the bottom of the y-axis. So that angle right there in radians will be 3 pi over 2. Now let's just look at a couple more examples. So we have tangent equal to 1. So that'll be 1 over 1. Tangent is opposite over adjacent. Okay, so this one is triangles. Okay, this one's not quadrantal because it's not the hypotenuse, that's 1. It's the opposite and adjacent, which are the two legs of the triangle. Okay, so tangent is going to be positive in quadrants 1 and 3. That's where our adjacent and our opposite have the same side. Here they're both positive. Here they would both be negative, so opposite over adjacent would still give us that +1 tangent value. So this is a 45, 45, 90. So that makes my reference angle pi over 4. So in quadrant 1, that'll just be 1 pi over 4. In quadrant 3, we're going to do pi plus our reference angle because we've gone past the x-axis, which is pi. So pi plus pi over 4, that's 4 pi over 4 plus 1 pi over 4. That'll give us 5 pi over 4 for that angle in the third quadrant. Now number 6, secant, that goes with cosine. So that's going to be hypotenuse over adjacent. Okay. So if I look here, my hypotenuse is the wrong measurement. I need these to be flipped for them to be a special right triangle. Okay, so I can see here my hypotenuse is too small. It's not possible for the hypotenuse of a triangle to be smaller than one of the legs. So this equation has no solution.